this recording, we are going to discuss human development. So we will first start with a few periods of what we consider overall human development. We're going to start with the pre-embryonic period, which is week 1 and week 2 post-fertilization. And just as a reminder, fertilization is when the sperm penetrates the egg, which forms a zygote. And this usually occurs within the uterine tube, specifically the ampulla region. Not always, just usually. Okay. Approximately 30 hours after fertilization occurs, the zygote begins to undergo a process known as cleavage. This is really just rapid mitosis. So we start with one fertilized cell, we divide. So we're growing in the number of cells, but the overall cell isn't, or the overall structure, I should say, isn't really getting larger. We're just having more cells inside of it. So if we look at our picture, we have ovulated our egg. We have fertilized with our sperm. And around day 1, we've got everything, all the DNA is now combined, all that good stuff, and we start cleavage. So we start 1 cell, 2 cells, 4 cells, 8 cells, but notice the overall size isn't getting any bigger. We're just dividing on the inside. And as this occurs, we are also going to start differentiating those cells. So we will start to form all 4 different types of tissues that will make up the normal human body at this point. This is obviously still very early. I mean, we're talking, 3 to 4 days. So this is very early on in the process, but we do start to decide which cells will become which type of tissues this early on. Now, somewhere between days 4 and 7 post-fertilization, we now call the zygote the blastocyst. So just a different term. This is what's going to implant. Specifically, it's going to implant within the stratum functionalis layer of the endometrium in the uterus. And so if we follow our structure, we continue to divide. Now we've kind of gotten to so many cells that it's hard to draw, okay? And it kind of misses the point at this stage. But again, by day 7, day 8, we have started to implant in this endometrial lining of the uterus, which is where the fetus, the embryo, the blastocyst, whatever you want to call it at this point, the endometrial lining, that's where we're going to need to be, because that's where the baby grows. All right, so next we go to the embryonic period. This is weeks 3 through 8. Okay, so the blastocyst, we're still doing mitosis, we're still growing in the number of cells, we continue differentiation, all that good stuff. Now we call it an embryo, okay? Especially by week 8, now we call it an embryo. We're also undergoing organogenesis, which is a nice fancy science word. And we know that genesis means kind of like to form, and then organo is pretty much what it sounds like, organs, okay? So this is where we start to take those differentiated cells that were becoming tissues. Now those tissues are going to come together and start forming primitive organs. This also includes the placenta. Okay, most people have heard of the placenta. That's where the nutrition for the baby is going to come from, the oxygen. It's how the baby's going to remove wastes, all that good stuff. This period, this embryonic period, is when the embryo is most sensitive to what can be referred to as teratogen. Okay, so teratogens, you may hear the term mutagen, kind of the same thing. These are chemicals or anything else that can cause mutations and or birth defects in the embryo. And some of these are completely detrimental and can cause fetal or embryonic death, things like that. So, all right, next comes the fetal period. This is the longest lasting period because this is weeks 9 through birth, which is approximately 38 weeks, but not always. Okay. Everybody's a little different. Every little baby's a little different, but 38 weeks is just kind of the norm. So as we progress through the fetal period, obviously we're now referring to this as a fetus. Okay, so we start with zygote, blastocyst, embryo. Now we're up to fetus. Continues to grow. We're going to continue to develop. The goal is to have created a tiny but fully self-sustaining tiny human by the end of this 38-week period. So differentiation is going to continue, organogenesis is going to continue, and then we actually have to grow the fetus just a little bit. Obviously, they still come out tiny compared to an adult, but they do gain in size quite a bit from that early little one cell stage. Now, just a couple of notable events that most people have either heard of, maybe you didn't really know what some of the terminology meant, things like that. So we're just kind of picking out a few notable events here. Obviously, there's tons of things that happen each day, each week, each month during the fetal period, but I just thought we would pick out a couple that were just easily relatable. So during the 3rd month, that is when the genitals can be distinguished as either male or female. Okay, so before the 3rd month, really, unless you do a DNA test, there's really no good way to know if it's a boy or a girl. Okay, male, female. After that 3rd month period, it becomes a little bit more clear. I think they usually wait just a little bit longer to do like the sex determination if the mother wants to know, just to give the fetus a little bit more time to continue to develop in utero. This is also when ossification begins. So if you remember back to our discussion on the skeletal system, remember that all bones actually start out as hyaline cartilage. Okay, and then we replace the hyaline cartilage with actual bone. And so that ossification process begins in the 3rd month. Now, in the 4th month, the heartbeat can be heard with a stethoscope. My personal experience, I don't think I ever had a doctor put a stethoscope to my pregnant belly. We had ultrasounds, but it's just kind of possible to hear. I thought that was interesting. By the 5th month, the skin is covered in lanugo hair, which is just really fine. A lot of people call it baby fuzz hairs, and then something called the vernix caseosa, which is this, I think it kind of looks like cottage cheese almost. It's this fatty covering on the fetus. Both of these, the hair and the vernix, these are to protect the baby from amniotic fluid. Okay, and then that kind of most of the lanugo hair kind of goes away by the time the baby's actually born. The vernix caseosa, a lot of times the baby will actually be delivered with this covering still on it. But again, just to protect against the fluid. And then last but not least, for the 5th month, interesting fact, this is when most fetuses begin to have movements that the mother can actually feel. So it's not really that the baby hasn't moved up until the 5th month. This is just usually when the mother can start to actually feel those movements. And this used to be referred to as the quickening way back in the day. I don't really think that's a term that's used quite as often in present day, but that used to be a pretty popular phrase way back in the day. Now, by the 7th month, the fetus has started to assume what they refer to as the vertex position, which is really just head down. So as you can see in this picture, we've got head down. Most births are head first, so that just kind of makes sense. And then by the 9.5 month mark, that 38-week period, that is when we consider the fetus to now be full term. Okay. If the baby is born before the 35th week, it is considered premature. And we all know that happens. Babies are born when babies are ready to be born, it seems. But before 35 weeks is considered premature. The 35th to the 38th week, I guess, is not considered. premature. I don't really know the science behind that, to be honest, but 38 weeks, that's what we aim for, if at all possible. All right. So let's cover just a few unique characteristics found in just the fetus. Okay, so these are things that start to develop during that fetal period. We mentioned the placenta earlier. We know that that's where the nutrients, the oxygen, all that good stuff is coming from. We connect, well, not we, the fetus connects to the placenta via the umbilicus. So we've got the umbilical arteries, the umbilical vein. There are 2 arteries and only 1 vein. Okay. The arteries, this is another one of those instances where the arteries are actually carrying deoxygenated blood. Okay. The vein is carrying oxygenated blood. Okay. So we know inherently that usually arteries have oxygenated blood, veins have deoxygenated blood. This is one of those instances where it is reversed, similar to pulmonary arteries and veins. Now, after the baby has been born, the umbilical arteries, they become the medial umbilical ligaments. So just fun fact. And then the vein becomes the ligamentum teres, which is sometimes known instead as the round ligament of the liver. So these things don't just really disappear. They just become new structures in the newborn baby. Now, we also have 3 shunts that are going to help us direct blood flow in a very specific manner while the fetus is still in utero. These are the ductus venosus, the foramen ovale, and the ductus arteriosus. Now, excuse me, the ductus venosus connects your inferior vena cava with the right atrium directly. This allows for blood to bypass the liver. Okay. We don't really have a whole lot of function of, not enough function of the liver while we're still in utero. So there's really no reason to pass all the blood through there like normal. Now, after birth, this becomes the ligamentum venosum of the liver. So again, not just disappearing, just becoming a different structure. Okay. The foramen ovale connects the right atrium and the left atrium. Okay, so normally the blood would go from the right atrium down to the right ventricle. We're skipping that step because we are going to bypass the lungs altogether. Most people know that when the baby is in utero, it's in basically a fluid-filled sac, that amniotic fluid. Babies don't really breathe air like we do. That's not where their oxygen is coming from. It's coming from that umbilical vein. So there's really no reason to send the blood to the lungs yet. So we just don't. Okay, we just bypass it. Once the baby has been born, that foramen ovale closes and becomes the fossa ovalis, located in the interatrial septum. Okay, so we're going to close that hole, and so blood now would go from the right atrium down to the right ventricle like it is supposed to. And last but not least, we have the ductus arteriosus. This is going to connect the pulmonary trunk directly with the aorta, again just bypassing the lungs. Still don't need them quite yet. Once the fetus has been delivered, the ductus arteriosus becomes the ligamentum arteriosum, which is a little ligament between the pulmonary trunk and the aorta. And so it just kind of holds these 2 structures in close proximity to one another. So after birth, all of these structures need to become something different because circulation basically immediately becomes what it would be in like an adult human. Okay, we have to go through the liver now, we have to go through the lungs now. So all of these structures need to become something else. All right, then we have the postnatal period. This is really just a lot of terminology. So if you see these terms being used in whatever scenario, you have a little idea of what we're referring to. So the postnatal period obviously begins at birth. So a newborn is considered fresh out of the uterus baby up through 1 month. Okay. By 2 months, we now call this an infant, up to 2 years. 2 years until puberty begins, we refer to that as childhood. Adolescence is when puberty begins up until we are now capable of reproduction. Okay. And then adulthood basically starts when adolescence ends. So basically, as soon as you're capable of reproduction up until death, that's adulthood. That's not necessarily what we would consider adulthood. We like to put ages, 18 and up is an adult. But from a scientific point of view, this just works a little bit different. There's really no need to get into a debate about which one is correct. It really just depends on, I think, the context of what you're talking about. And then just another good term, senescence, degradation of tissues and organs starts to begin as you move through the adult life. Eventually, everything kind of deteriorates to the point where it shuts down and death is inevitable.